Okay, welcome back, guys. Welcome to today's lesson on ETABS. In today's lesson, we are going to be learning how to calculate the area of steel required for the links on ETABS. So ETABS has given us area of steel. These values are just area of steel for the links and torsion. As you can see, shear plus torsion. So what we do is you can create an Excel sheet, which I've done. This is it. So you give it a name you want, stir up ETABS. You put the breadth, that's the B, 230. You create the depth, 450. Then what diameter of bar do you want to use for your stirrup? So the bar diameter I want to use for my stirrup, for example, is 10 mm. So I can decide to use 10 mm. I'll select that. Then I will come back here and automatically it will calculate the area of steel for me. To calculate the area of steel for 10 mm. So you can see for 16 mm what it gives me: 16 mm 201, 12 mm 133, so 10 mm, this is it, and 8 mm. Okay, this is what I'm using. Now, number of legs. So when we say number of legs, this is what we mean. Or in this, let's say we have our beam. This is our beam shape. Now the stirrup will be inside something along this. Let me reduce the thickness. Let me increase it so you know the difference. The stirrup, okay, inside. So when we say number of leg, this is leg 1 and this is leg 2. So we have 2 legs, leg 1 and leg 2. It's possible for us to have 4 legs also. I can create another one inside. Okay, something like this. So this is another. This will be leg 1, leg 2, leg 3, leg 4. So now ETABS, I want to use 2 legs because our width is small. I can only take 2 legs. So number of legs 2. So ETABS area spacing. So now ETABS has given me this value. Okay, ETABS has given me a value. Let's use this one. It has given me a value of 641. So let me say 642. 642. Click OK. So I can tell ETABS that I want to use 8 mm at 150 center to center, or I want to use, let me use 10 mm. I want to use 10 mm at 225 center to center. So it's always good to put it at every 1 inch spacing, because on site that's what they use. So it's either use 25, 50, 75 at every increment of 25 mm. So you can see it at 10 mm. So what will happen if I change it to 12 mm? I can use 12 mm at 352 center to center. So you should always check your code for the maximum spacing required. So in this case, I want to use 10 mm. Okay, so my 10 mm is at 225 center to center. That's what I want to use for that particular place. Then at the particular medium, if I put 340, let's see what it gives me. 340. 340. I can use 340, so I shouldn't exceed 300 center to center. So I'll just use Y10 at 300 center to center. So in your detailing, you can decide to detail it from here to here and say you want to use Y10 at 225 center to center, while from here to around this point you want to use Y10 at 300 center to center. Yes, that's the accurate way of detailing. But in our way, we are going to just select this and use a uniform link all through for this particular beam. So let's look for more beams with more critical loadings. Okay, more critical shear. Let's look for more. So I think this one too has failed over shear. Okay, so this one has a value of 1340. Let's say 1340. So 1340. So I'm telling ETABS now that I'm telling my draftsman, or ETABS is telling me that I need 10 mm at 100 center to center for that particular place. So what we are going to do to resolve the issue of this failing beam is, since it's the school and they don't mind this, we are going to increase the depth, or we'll increase the depth to 600 or through. So we believe it will pass that. So thank you for watching today's video. In the next video, we'll check if 600 will